So what we are going to do is to use stat.blue, a free statistical software, to draw a histogram of this free throw percentage by these top 250 players of the NBA. Okay, so let's see how we work on it. So first of all, we have to do this. Let's just go ahead and copy the data on clipboard, or we shall do that later. Let's just first start stat.blue. So first let us enter stats.blue, and remember to enter stats because stat.blue will take you somewhere different. So I hope you can read it. Otherwise, let me try enlarging it because okay, so here we are looking at one variable statistics. Okay, so let's just go ahead and look at the statistics or the data that we were looking at. So we shall copy this data from Excel here and then just go ahead and paste it in here for data. Okay, and as I say, you can use any other software to do your homework, and this is what? Free throw percents. Okay, all right, so I just typed it in, and then so with let's just first calculate the okay, all right, we have to enter a bin width, so let's just put a bin width of, say for instance, 10. Okay, all right, so here 10 was not a good bin width, and we will see how we determine that. So here you can see the mean is 83.3. You have all the summary statistics, and we are looking at the top 250 players, and the minimum free throw percentage rate among them is about 80%. The maximum is about 91%. So the bin width of 1 was not really very good. So I could have gone with a bin width of, bin width of 10 was not very good. I could have got, started with a bin width of 1. Okay, so let's just go back and ask it to do the same thing again. Oh, I'm going to re-enter the data here. Free throw percents. Okay, and then sorry about that, and then we have this here. I'm putting the width bins in here, and let's just go for percent is okay, or you can go for counts in histogram. So here you go. I mean, it is skewed to the right slightly. All right, so we got all that, and we will have a box plot. So we have a display and the descriptive statistics here. Okay, so here let's look at data for making comparisons. So here we have a data for of the hemoglobin readings versus the gender, and so I just stacked them in two different columns, women and men, so that we can take it over to stats.blue. So there are how many? 27 women in the data. So when we go back to stat.blue, now here we are looking at multiple variables, like more than one here. So we got here, and in case you want, you can add more columns in here. So in here, I'm just entering the reading for women, and then I'm going to bring in the same reading for men. Okay, so for men, the reading is this. Let me just write men on the top. Okay, and bin widths, let's put the bin width as 0.25 here, and title of the graph, so we can just put hemoglobin level. Okay, I may be making spelling mistakes. All right, and say calculate. So here, so what we have is, so first of all, we have the histograms of women and men, and but for comparisons, the box plot would be better here. And then here we have the summary. So you can see that for the women, in the summary we have what you would expect. I think the data for women should have For males, it ranges from 14 to 18 gram per deciliters, and for women, 12 to 16. So in here, what we are finding is this for, yes, so here is going like about from 11 to 15, and for males for about like 13 to 16, right? Okay, and here are the histograms, and then you can look at the comparison of the box plots, and it is what it is expected from the general data. There is some departure from that National Institute of Health data. So you can perform various tasks from this free software, stats.blue, and let's see, and let me know if you have any questions. Okay, thanks.